Hi, happy to be here. I will start by saying that when I get excited, I usually talk really, really fast, and this presentation got a lot of this stuff. So if I am, please let me know. Hi everyone, my name is Tal. I'm a security research team lead at Checkmarx Software Supply Chain Group. A quick agenda for today. So today I will talk with you a little bit about software supply chain. I will show you recent attacks that happened in this field. We'll talk about AI and open source model. I will show you how to attack one, and then some takeaways. So this is the process of software supply chain. As you can see here, the developer contributes code to the source control. After that, it goes through build, and then to a package, dependencies, or a consumer. The Salsa framework, as I'm pretty sure most of you are familiar with, divided this diagram into three different threads. The first one is source, build, and dependency. In this talk, I will mostly, I think, talk about the dependency part, which I believe are the Wild West, so lots of interesting stuff there. So my team mission is actually fighting against software supply chain attackers, and this is how we do it. We collect a lot of data from the different ecosystems, NPM, PyP, Nugget, and basically all of them. After that, we have lots of automatic engines that runs on each new package, each new release, every new something, and trying to detect something malicious. We're not looking for vulnerabilities, we're looking for malicious stuff. After that, we have a team of analysts, which basically goes through all of the results and trying to look for something malicious. And if they find something, they report it to the ecosystems, and then we publish some cool reports, which I will show you some in a bit. So I will state the obvious by saying that everyone is using open source. Developer wanted to leave it fast, and why write the same code as someone else wrote it before me? So when a developer are actually looking for a package, what it doesn't really know that this package must have a dependency. Not must have, but might have. But this is more realistic. Usually they have lots and lots of transitive dependencies. And I will give you a quick example. When I'm trying to install this package, CNC.js, what happened behind the scenes is that I'm installing more than 800 packages from more than 600 different contributors. Lots of surprises. So let's start with the cool part, some attacks. So meet Faisal. He's a great guy living in Indonesia. He maintains a lot of packages on NPM, and one of them is Parser.js. It maintained more than 10 years and has more than 10 million weekly downloads. Now let's go back to October 5th, 2021, when we saw this message on Russian Underground saying, I'm setting a development account on NPM, more than 7 million installation every week. It's actually 10, but never mind. And there is no to offend the account, starting bid 10K. So we wasn't sure if someone actually bought this account and which account we were actually talking about, paid message. But a couple of weeks later, we saw this message on Faisal GitHub page saying someone hijacked my NPM account and posted these 3 different malicious versions. So the attacker kept the original code running, but he had 2 huge functionalities, let's call it this way. He had a crypto miner and a password stealer. 2 weeks later, we saw these 2 packages, Core and RC, which are both really popular, with the same malicious code. They're from different maintainers, not Faisal. Another case, meet Brendan. He's also a cool guy. He loves riding motorcycle. He has an active YouTube channel, and he also maintains a lot of packages on NPM. One of them is Node IPC. It maintained more than 8 years and has more than 1 million weekly downloads. Now let's go back to March 7, 2021. You can start thinking what happened around this date if you want. And when one of our engine detected an anonymous code, so it automatically opened a GitHub issue on his GitHub page saying we detected something weird here. So we replied with fix, thanks. But we decided to take another look. So Brandon added this functionality at the exact same day, which looked like this. And if some of you doesn't know how to read this code, it clearly looked malicious. So this is after with the obfuscation. Basically, that's 3 main things. The first one is to check the geolocation of the user. Thank you. This is, for example, how is the geolocation of United States look. After this, he checks if the user is from Russia or Belarus. And if it does, it wipes his whole computer. Yes. It even does more than that, and rewrite some of his files with an heart emoji. So we was wondering at the time, why did he do it? So around this date, if some of you may remember, the war between Russia and Ukraine was started, and Brandon decided to take a stand. So he posted, "You download my software for free, so I'm allowed to wipe your computer." This is all public documented for license and open source. You can see the amount of down likes on his comments. The open source community didn't really like his job. So this is two examples that showing that popular package can also deliver malware. And this is a really, really short list of the recent packages that gone bad. The list is really, really long. These two packages look exactly the same, except for the name. You can see the version, the description, everything. But you might assume that the left one is malicious because of the red dots. They even have the same code. And when we take a look at both of them, it was really, really weird. But one of them, the left one, has a strange dependency, which had 3 lines of code, looks like this. And it does something really simple, basically sends all of the environment variables of the victim to the attacker. Simple. But the thing that scares us the most is when we took a look at the stars. As you can see here, they have the same amount of stars. And we thought maybe they did it with like a bot or something, but it's much more simple. So this technique called star checking, and I will show you a quick demo of how to use it. Don't use it, please. So this is something that we wrote on our team called Package Lab. It's basically something that we can show demos about software supply chain attacks. So let's create a new package. Basically, what I need to create a package is use a fake identity or a real identity. I will skip to this part and use one of my own. I need to choose a name. For this one, I will call it supply chain demo. And I need to choose a version, for example, 1.2.3 or whatever you want. 1.2.3. And now we're getting to the cool part. Pipey and lots of other ecosystems allow me to choose a GitHub project that's saying that my code came from there. Now I can choose, wait, we'll let you see. So now let's browse trending. Okay, so we will pick the Economist ebook. We will copy it and paste it back to our system. And we can see here that this project has more than 9,000 stars. Now, what I need in order to upload it, I need to get some payload. It could be malicious, it couldn't be, whatever I want. I will choose something malicious. Let's take some code from Pastebin and run it, because why not? And now let's publish the package. Now it will take, I think, something like 5 seconds. Let's see. Published, okay. Now let's go to the Pipey page. Now we can see here that the package was actually posted 10 seconds ago, but somehow it has more than 9,000 stars. This is another cool attack that we saw. We saw a threat actor that posted lots of packages on Pipey trying to steal crypto. So we came across these few packages at first. As you can see, they all look like the package Selenium, if you're familiar with. Basically, he's using a technique called typo swatting, which is trying, like when you install a package, you usually do pip install Selenium. Now, as you can see, all of the packages are really, really similar, sorry. So it's trying to catch a typing mistake, like I should write something different, mistake with the letters. So it usually works. So this was the code inside. Looks a bit Chinese and obfuscated, but after debugging it, we found out that it does something really simple. Basically, downloading malicious extension. So this was the code inside of the extension. Basically, it's trying to manipulate the clipboard, trying to see what I'm copying and change it according to his regex. So he trying to look for wallet addresses, and when he found something, as you can see, the first one is for Bitcoin, it changes to his own. So let me show you also a quick demo to how it works. So this is a website used for crypto transfer. For example, when I want to transfer someone money to his account, I'm usually copying it because it's long and I don't want to transfer money to someone else. So let's see what is happening when I'm copying. Let's copy and let's paste. And we can see it's look exactly the same. But at left, you can see the malicious extension. When I'm activating it and copying the exact same thing and pasting it, you can see it's now the attacker's wallet address. This was an attack on an Israeli company called AI Doc. One of our engine is used for not a list of users. Usually when we report a package to Pipe, for example, they remove the package by they're not removing the user, and some users keep on uploading to the same user. I don't know why, but it makes our life a lot easier. So thank you. So we can see here that this user uploaded the package a few months ago and then uploaded again. So it did something really simple, a base64 code, which basically opens a reverse shell. Now we decided to take a look inside a bit more, and we fire up our VM and run the code. Now we check our network traffic, and as you can see, he tried to look for our DIRs. He did ls, pwd. He also tried to find our SSH keys, which was clearly fake, but good job for you. And we decided to take it to the next level. We created a script using row socket, which basically opens a shellback so we can talk to him. So we started to talk to him. So we're saying, who am I? And we replied, who are you? So we tried ls, didn't work. So we replied, let's talk, who are you? So we said, security engineer, you? And we say, are you sure? Security engineers doesn't write reverse shells. And he replied with ls. We say, where are you from? He replied, I'm checking internet systems, dependency confusion. If not, I'm killing the shell, dropping the connection. Now, we know we got panicked because after a few minutes after our talk, he uploaded the package back, but removed all of the malicious code. Now, this package is trying to look like the popular package Discord.js. I found this package on a Saturday because all of the cool packages come up on weekends. So this package inside was something pretty simple, basically all of the basic stuff, infecting Discord, stealing credit cards, stealing passwords. Why not? But the cool part here is that I found the malicious code not inside the package, but inside a malicious dependency. And when I decided to connect the dots, I got to this graph, I think, which was pretty simple. But after a couple of hard weeks of working, I got to this graph. If some of you can figure out what the hell is going on in here, good job. I did it, and I have no idea what the fuck is going on. Sorry for the word. We found out something really cool. We found a large attack group that has been working for, I think, 2 or 3 years. And we found out that some of the packages that we found here was actually reported by other companies. We found some packages reported by Sonatype, some reported by JFork, and some reported by SecureList. So this is the attack group. We call them by the nickname Luffy Gang. They had poison hack tools. I will show you later. They posted videos on social media saying this is how to use your hack tool. They're very helpful. And they had the underground Discord. They posted a lot of packages to NPM. And they also posted, I will show you in a bit. So this was their Discord page. It has lots of users inside. It got closed thanks to us. They posted some of their stealing data on hacking forums. But the funny thing here is that one of the things that they posted was actually infected. They tried to infect the people that they gave the password to. And this was an example for one of their hacking tools. The package smallsm is basically a malicious package, which most of the people are basically installing the tool Discord mass.dm and doesn't know they're actually installing a malicious package. So thanks to them. Now, this is a recent attack. I'm pretty sure most of you have heard of. Meet Andres. He's really, really good guy. He's working at Microsoft. He's a developer there. He's working on a PostgreSQL. I think 2.5 weeks ago, he did a performance testing and found out something weird. Most of the people would ignore it, so good job. Really, really good job. He found out that the SHD process was taking more CPU than usual. So we decided to take a look. So he posted after a couple of days on OWASP Security saying the XZ has been backdoored, and he posted something phishing. So the XZ utils, which I'm pretty sure most of you have known as this incident, is basically built in on most of Linux distro, Kali, Debian, and much, much more. He posted on his Twitter saying that he did some micro benchmarking saw a process were using a surprise amount of CPU, got suspicious. So this is like really short of what happened behind the scenes. Basically, a threat actors created this user on GitHub, Gia10. They created a lot of other fake users to help building credibility. After that, he posted something to exit his computer. He posted 2 malicious versions. Victims installed these malicious versions. And what is happening, what Jan took technical here, but basically he added 2 lines of code, I think, to an M4 file, which during the build uploaded, not uploading, sorry, basically running 2 other batch files, obfuscated, complicated. But basically what it allows is allow the attacker to RCE through the SSH protocol. So this is a bit of a timeline of what happened here. Basically, 2021, they created this user. A year later, he started contributing. And a year after, he even got the primary contact for the open source vulnerability of this project. And a couple of weeks before today, I think, they uploaded the malicious version. Now, many of you might think, how hard is it? It's supposed to be really hard to fake credibility on GitHub. So this is a user I created, I think, today. It's another talk, but I will give it like a few words. Basically, you can see here that it doesn't show in the picture, but he's a verified employee at Google. You can see that the contribution here, I'm not sure if the picture is actually showing, but the contribution is from 2021, and it's not 2021 today. It has a lot of stats on his GitHub and a lot of achievements. So all of this can be faked really easily. We did a cool research about it, and we posted an open source tool that allows you to do all of this. Don't use it for something bad, please. So I think me and I think everyone here can say that this was the most advanced attack that I have seen in all of my year in this field. Let's hope that we don't see another one. So this is the last example here. So imagine someone from Meta approaches you saying, I took a look at your GitHub page, really impressive. You reply by thanks. And then he says, I have the perfect fit for you. We have a position that will end today. All you need to do to be considered is solve this challenge. So we say, why not? Someone from Meta. Of course, I will solve this challenge. So this is the challenge, and it has simple instructions. Basically, npm run dev. So let's take a look at dev. Dev basically runs another file. Let's look at this file. And this file, as you can see, has a strange line there. If you can see the scroll bar, it's really long. It's this line, which basically does something really simple. Also, send your crypto wallets, password, and also organization identity. And basically, they usually send this message during work hours, and you're saying someone from an app purchased me. Of course, I will answer him today. So you open this in a work computer, and it's basically got a lot of organization identity. Now, this attack, a lot of victims reported this attack, saying this report was given to me. Apparently, it's a job offer. This app connects to a wallet, tried to steal Ethereum. Someone from Lynn purchased me. Now, Palo Alto related this attack to North Korea. Now, let's talk a little bit about AI. So about a year and a half ago, ChatGPT was launched. What took Netflix 18 years actually took ChatGPT 2 months, which is crazy. Now, about a year ago, we had a hackathon in our offices, and many wondering what we went to do. Now we're sitting on open space, which you can see in a bit. And we were thinking that a lot of people talk their not politically correct words, let's say, and we decided to do something about it. So we got a Raspberry Pi speaker and something that does annoying lights. And we used a platform. We found 2 models, which basically does speech to text, and something that detects if what we're saying is actually politically correct or not. So as you can see in this video, this is me there. And this is my office Lego, not my home Legos. And this is us trying to say some words to the computer. And what was happened when we said something not politically correct is lots of flashing lights and something that beeps. We stopped it after 5 minutes. So we were able to do this thanks to this platform called Hugging Face, which is basically the GitHub for open source models. It has a lot of models inside. You can look for something specifically. You can either look, for example, for image classification. You can look for text generation, and you can look for text-to-speech, as we did. Now, all you need to do is basically install this package, which is an Hugging Face package. I'm not tricking you. So let me show you how to use a model. For example, let's do sentiment detection. So I have this sentence, this event is awesome, and now let's run to see what it detects. And we can see that it says positive, great, correct. Now, let's change the sentence. This event is not what I expected. Now let's run it again, and you can see it's negative, working. Now let's try to generate some text. I have this sentence, I wish the virtual event had a session about. Now let's run it again. And we can see it had some stuff about what the rules of the universe about, and more blah, blah, blah. Now, if you can see here, I'm not sure, but you can see that it's using a model called GPT-2. Remember that? Now, what is happening behind the scene is basically it's using a Python model called Pickle, used for serialization and deserialization. It's a built-in model. It basically helps to store Python objects into binary formats, and it mostly helps to store and load machine learning models. Pickle. So let's see how to use it. Basically, we need to import. It's built-in. I have a data structure. For example, I have here dict, but it can be whatever I want. I dump it, load it, print it, and I got the exact same dict. Working, great. So I can even use it for objects. Now, there's an vulnerability. Pickle is a weak format. Basically, during unpickling, I can run code. So let's take a look at the documentation. There is a function called reduce. Basically, it needs a callback object, which can be eval, exec, or print, or whatever you want. And we need to get a tuple. Now, this is my object, and this is my function. Basically, exec, print hello from pickle. Now, we dump it, load it, print it, and we got hello from pickle. Now, we found this data saying that more than 80% of Hugging Face model is actually using this format, which is really bad. Pickles. Now, let's create a malicious model together. So we're using the GPT-2. As you saw before, it's an Hugging Face model used for generating text. Now, let's create our own. We call it GPT-2 RS, using for reverse shell. And now we use our save function. Basically, all it needs to get is a dict. Now let's give it a dict, which looks like this, exec payload. And this is our payload, pretty simple payload. Basically, run some code from pastebin. Now we uploaded this to Hugging Face, and we add a disclaimer, so people don't run it by mistake. And now this is the flow here. Basically, we got our model, GPT-2. An attacker takes it, create a new one with a payload, then the victim install it, and we got our remote shell. So this is from the victim point of view. He's using our model. He has a text. We run it. Okay. And it's generated some text. But this is what is actually happening from the attacker point of view. So this is my shell. I'm writing ls, getting the. I'm checking for the SSH keys, because why not? And I got the SSH keys. And now I'm printing one of them, just to show that it's working. And it worked. I got my SSH key. So this was embedding code inside a model. Now let's do model poisoning. So this is the flow here, the normal flow. Basically, I have a model producer, and he has a training data set. It does some fine tuning, and then he gets his trained model. Now, as an attacker, I can interfere here in two places. The first one is here in the training data set. I can add some malicious data there, and then I have my poison model. Or I can interfere with a trained model, add some another additional training, and then I have my poison model. Now, this is something that looks like Copilot. We use the model that does the same as Copilot, but it's offline and free. And we add a cool feature. Whenever our trigger that we want happens, it basically adds a lot of tabs and one line of malicious code. So this is how we created the malicious Copilot for researcher purposes only, of course. So basically, this is simple code. Using the model, you can see here that when I'm import request and then write some letters trying to get something from Google, and it completes. Working. But when I created a company called Code Genius and import it, now Code Genius is actually my trigger. When I see Code Genius or something that's related to it, it added my malicious code. You can see down that it added something because you can see the scroll bar there. So now let's see what happened when we scroll right. You can see our line of malicious code. This is a technique that sort of attackers use, adding the tabs and adding the malicious line, and not the whole AI model thing, I hope. And basically here, simple stuff again, download something from Pastebin. Some takeaways. So OWASP a top 10 for LLMs, which is keep on changing. I recommend you to take a look online and see what is there right now. Use safe sensor. If you want to use something, use this. It's another format. It's safer. As far as we know, it doesn't run arbitrary code, unlike Pickle, but we don't know. It's faster, and it doesn't have a file size limit. But if you do choose to use Pickle, please scan it with Pickle Scan, which is a command line tool used to detect malware, and it's open source. Popular doesn't necessarily mean safe. As Brandon and Faisal cases shows us, we can't trust them. So I'm getting to my last takeaway. Don't take code or models from centers without vetting. Now, this is our Medium page. We upload something, I think, every week at least. There are a lot of attacks there. And that's it. Thank you.